So today we're going to talk about the Doppler effect. So I'm sure you've been in a situation where you're just on the street and an ambulance is passing by, and as it gets closer to you, it seems like the sound of the siren is getting louder, but then as the ambulance drives past you, the sound of the ambulance diminishes. So this has to do with the Doppler effect. So let's get started. The first condition for the Doppler effect is that the receiver has motion relative to the medium. So I'm going to write that down. Receiver has motion relative to the medium. So the medium could be air, water, something else, but the Doppler effect can't work on something that's like strictly stationary, not moving. So as we saw in the example I gave you, the ambulance was moving. So this means that the receiver must be in the same frame of reference for the Doppler effect to occur. Okay, so essentially the Doppler effect is when you have multiple measurements for frequency between the source and the receiver. So I'll give you another example. Let's say somebody is playing A flat on the piano, but you hear A sharp. That would qualify as the Doppler effect. So I'll also note this down. So how we note this is F sub S is not equal to F sub R. So source, receiver. So over here, the source is making a sound. This is the source. While the receiver is running towards you. So over here, we know that VSM, so the velocity of the source in the medium, is not equal to 0 because, as I explained, the receiver has to have relative motion. And the other condition is that VRM is equal to 0. Oh my gosh, I'm so sorry, that's another mistake. So there we have it.